You are watching EduSet lecture, and friend, as you know, we are discussing a statistical package. Yesterday we had one introductory lecture. Today we will move further on and we'll discuss the SPSS, another software available for the use of data analysis, and we have the same resource person, Dr. O.P. Wali, for the discussion on this very topic. Dr. Wali presently teaching at Indian Institute of Foreign Trade, New Delhi, and also before moving to this organization, he has worked in National Dairy Board and at Indira Gandhi National Open University. So I hope his knowledge and experience will help us to understand this software, the better use of this software for the data analysis. So on your behalf, I welcome Dr. Wali for EduSet lecture. Welcome you, sir.
Thank you. As we had an introductory session yesterday where we just talked about the use of statistics in marketing research, and then we talked about the application of software tools in really making this whole process efficient. So we gave an overview about the SPSS software, which is a very popular software for statistical analysis. Today what we are going to do, we are going to show you a couple of softwares, starting with SPSS based software, which is used for the normal statistical analysis, and then we'll move on to another software of the same company, which is called SPSS Clementine and now known as IBM Modeler. So then we will take up a marketing example and show you how we use this particular software to resolve decisions which confront us in a marketing situation. So that is the agenda. So to begin with, let us first have a quick look at the software which we are going to use today. So what I will do, I will just first open the software, SPSS software, and I have installed it on my desktop. As I told you, it needs to be installed first, then you can open the software, and just I have clicked the software here, which is under the programs, and the software will open. And so this is SPSS 17 version, which has a lot of say interesting features and additions vis-a-vis the previous versions. So the idea is to give you a brief say overview of the features that are there that we discussed yesterday. So can we have camera on the computer? Okay. So this is how the software will open up, and now what I have done is I have already created a file here on my desktop. Is an Excel file which I have created, which I will procure into the software. So this is a simple file where what I have done is I have just created three variables, and the variables are income 1, income 2, and the third variable is gender. It's just for demonstration sake, nothing to do with some reality. So what I will do is now I will close this file, and then I will call this file in the SPSS. So I will go here to the file, and can you just have a computer on the screen, and I will go to the file, I will go to the open, and in the open I will go to the data, and in the data I will go to the desktop, and in the desktop I will open the folder which I had created, and here I will give the proper extension, Excel extension. Now this file is visible over here. Now I just click it and open it, and it asks for certain say basic requirements before it really opens up. It says read variable names from the first row of the data. I have given it a check mark because the variable names are given, which I told you, income 1, income 2, and the gender. And worksheet, worksheet number 1, because we have all the data in the worksheet. In case we had a specific range which was there in the Excel worksheet, which we had to call in the SPSS, then we will specify the range over here, which is not the case in this particular situation. So we will say okay. Now we will see the data has appeared over here. Now this has some additional 2 rows. Just let me just clear this. Now we have the same data which was there in the Excel file has appeared over here, and this is the data view which we discussed yesterday also. Now if we want to look at the variable view, we just click the variable view, and you will find that these variables are appearing here with their complete definition. That is in terms of the type. So the first two variables are numeric variables. The third variable is a string variable, gender, because it is a categorical variable or a qualitative variable. And then the width and decimals, labels, values, missing, columns, alignment, measures. First, let us look at the values. Let us say we want to really understand, we want to have, say, values and the labels for the variable like say gender. Let us say value f is given, which basically is an assignment to the category, and we say it is female, and we just click add, so it has got added over here. Then we have another category which is male, which we have which we have punched as M, so we will write male. So we just do this and say okay. Now what has happened is, if we go to the data view back, you will find these F and M has got translated into male and female. Now if we press this particular icon, which we yesterday also discussed in the previous session, if we press it, you will get the label, otherwise you will get the value. Now let us quickly look at say how we can really use analyze feature, which is the most powerful feature which we talked yesterday, which implements the most of these statistical techniques and models, and see how we can really use one of the features to give you a flavor of the software. So we go to descriptive statistics is the first thing. You have all the possibilities over here. You can calculate frequencies, do more, say, elaborate descriptive statistics over here. You can go to explore it further, and you can do cross tab in case you want to really put it in a contingency data into contingency format. Now let us just try to do, say, frequency to begin with. So let us say we just have this gender, we take it here, and we want to check, say, let us say the mode, not mode, I will say, I will not take this thing, I will take, sorry, I will take the income and take it here, and take another one also, take it here, use statistics, the mean, and let us take standard deviation as, say, two statistics to calculate. I say continue, and I say okay. Now say you just press up a button, you guys are able to really calculate whatever you really want in terms of the statistics. So we have all the data output appearing over here. So there are 100 records over there. There is no missing record. The means of the two say columns are given over here, and the standard deviation is shown over here. Now quite possible I may really try to analyze this in terms of say what to call as let me take the another one, and descriptive explore a particular income variable with respect to let us say gender. So I say this income one and put this in gender as the factor, and want to calculate statistics, descriptives, and continue, and I want let us say plots rather than this thing. I will use an histogram. I just check it, and I may be using these variables later on for any kind of analysis. Then I would like to really check whether the data is normally distributed. So I just say continue and say okay. Now you will find here that the output will appear over here, and it will give us all results that we have really asked for. So the gender, if you see here, we have 61 females and 39 males, and there are no missing cases, and we have been able to categorize the numeric data based on the categorical data that we have procured. So the numeric data is income 1 in our case. So the income of females, if you see, is 70.44 mean, and whereas the income of the males is mean is 70.47, standard deviation, minimum, maximum, lower bound, upper bound. So everything that you really need for say the first insight into the data, that is all available through this particular feature of data exploration. And you see the histograms over here. If you see that both the say data sets, I mean the income across males and females, first one is for the female and second one is for the male, are normally distributed. So we are able to check visually whether the data follows the assumption called normality, because this will be very, very handy and a required assumption in case we want to really apply various statistical techniques. And similarly, normality plot is also provided by this particular feature, because whether data is really following the normality can be checked with this particular QQ plot as well. So this was a brief about say this particular facility, and then I would just use another feature in the this thing is in the software, in the analyze this option is how to compare the means. So there are a lot of possibilities which you must have really read in statistics, but how do we really use SPSS to do that? So first is just simply comparing the means, and I will just click this comparing the means. I will take let us say income over here, and I will take gender over here, and I will take options, and I will just say continue. I simply say okay. Now what has happened is I have been able to compare the means of the first variable income across the gender. So the mean of say income for the female versus male can be seen over here along with the standard deviation. Now I may be interested in comparing the means, let us say a paired sample t-test. That is in a case where let us say we calculated income of say a group of people at some point of time, and later on try to enhance their skills, and again got back to them and again calculated say income from income earned by these people, and we are trying to really compare whether there is some significant difference from the earlier status. So what we can do in that case is we can just compare the first and the second, putting like this with 95% level of confidence, and I say okay. So now what is the result telling us is here in the output, which quickly appears over here. So the income one, the earlier case, the income one, let us say the income one was the earlier status was let us say 70, and income two is after some intervention it is 65. That is, the income has actually decreased, not decreased rather than increased. And is the decrease really significant? That has to be seen with the help of the level of significance. If it is 0.896, means it is not really significant. That is, whatever decrease has actually happened, we got to really see over here the paired sample test here, so is really significant. That is the t-test shows us t value is t 5.302, and the level of significance is 0.000, which is quite lesser than 0.05. So it's 95% level of confidence. Even with 99% level of confidence, we can easily say that the difference which has really happened is statistically quite significant. So similarly, there are a lot of other things which can be really applied using the basic this SPSS software, which includes more than two groups, which can be handled with the help of ANOVA, and then say multiple dependent variables with the help of say another technique called MANOVA, and we may try to find same dependencies across variables or the causal relationships using say techniques like regression, logistic regression, etc. And we can also use reduction techniques to reduce the number of variables, or say find internal consistency across the variables using various tools which are there available with the SPSS. So this was just a basic introductory exposure of this particular software, and we will handle this software in the coming sessions in much more detail. But what I want to do now is take you to the another software from the SPSS, which is called Clementine, and which is a very powerful software, at the same time very simpler to use. and it needs a bit of practice to really use this kind of a software. But the way it really handles marketing problems and resolves your issues is quite mind-boggling. That is, let us see how we can really use that kind of software. So I will just close this software up now and move to the other software which we call Clementine. So when you typically open a IBM model, or what we call as SPSS Clementine earlier, it looks like this, which has this this particular area which is the canvas where we draw the model. So what is the model, you will really see in a small bit of time, and then here this particular portion you will see that whatever outputs we generate, whatever models we generate, everything their whole archival will be put over here. And because now the process of modeling has become very common and it is done extensively and a lot of standards have developed. So all the software developers who have developed these kind of say products have put in place a kind of a structured methodology in their software as well. So if you want to really do say systematic modeling, so you can use this kind of a feature where you can put phases of the modeling process in different folders and can really manage it individually as well as in a very collaborative manner. So down below in the software, if we now look, we have all these say palettes over here. So favorites, if you see the first one, may look very common to you because favorites is always in most of the softwares, means whatever options you are using quite regularly will feature over here. But the actual say the options here are, first is the sources, and the sources is meant to really get connected to a database or data sets or data wherever it is located. It can be on your laptop, it can be on your workstation or desktop, or it can be somewhere in the company servers or the network. You can hook onto that using proper connectivity. So you can have an Excel file, you can have a SAS file, you can have an SPSS file, you can have a flat file. So any kind of input can be really accessed using this particular facility. So what we will do is to begin with, if it is a flat file, I will just drag this where file icon over here and just double click it, and this kind of a feature will blow up here. Now what we do is to access any file, we will press this particular button over here. So what I do right now, I just call one of the demo files for demonstration purposes here. So I take this file, I just click it, open it, and this file data has appeared over here. So if I want to quickly see what kind of data is it, I can just click here. I see the fields of the data over here, and I see the complete detail of the data in terms of type, their say measurement, everything is shown over here, which we'll discuss very shortly. So what I do next is that I want to see what kind of data is it. So what I do is there's a facility here, output. In this output, there is this particular icon over here, table. I just bring it over here. I just connect this data source to this table and simply execute it. And you will find that all data that we have connected here appears over here. So once you really get the data on your canvas, the first thing that we try to do is to look at it and see what kind of data is it. Why would like to really see that? We discussed it yesterday also, that before we analyze the data, we got to really clean it, see whether there are some missing values, etc. So to get a kind of a smell on the data, this is the feature that can be really used. So this was the first option over here, the sources. So the second option which is here is the record operations. Record operations, and then we have the field operations. What are these two things? See, whatever analysis we are doing, it is basically trying to tackle two things. One is variables and second is the cases. Or variables could be columns and cases could be rows. So we have to really clean them, prepare them for the analysis before we do apply the analytical model. So whatever we have to do with the records, let us say we have to really add records together. To disaggregate or aggregate the records, we can use the record option for that. In case we have to really club two columns or two variables together, we may use field operations for that, because field is nothing but the variable. Or we may have to eliminate a particular variable, we will use again the field operations for that. We may have to really designate a particular variable for any kind of an operation. Whatever we want to do with the variables, we will do it through field operations. That is what these two tabs are really meant for, and the facility is there. We will soon see how we can really apply that. So after these two facilities over here, then we have the third thing, fourth thing here is the graph. And the graph, you have a lot of tools over here given, which help us to really visualize the data, explore the data, which is a very important step in the exploratory data analysis. That is, before we actually apply any model, etc., we would like to really explore it, see it, whether there is some visible pattern which can be really seen with the eyes and which can be really depicted through a particular graph or chart. So that is what these different tools are there really meant for. And next, if you see is here, if we press it, you see all possible models are here. These are plenty of models, and these keep growing year after year, because these software companies, what they do, so whichever models are becoming very popular among the researchers, these models are being adopted by these software companies for application. So you have all possible techniques over here, call it regression modeling, association, classification, neural networks. So all host of models are available for your use. And then finally, you may like to export this particular model you have created to another team which may be in the same location, another country. So if you are working in a very big company, you create such things and try to really work in a very collaborative manner, and that is the purpose of using this particular software. Now let us apply this software in a particular retail situation. So retail, when I'm saying, I'm typically talking about a marketing problem. So in a retail outlet, if you see that there are different decisions that are being taken by different people at the different levels in the organization. So one particular decision could be that in the next season, what items we would like to really put on promotion, and that would depend on like you may have, let us say, hundreds of products, or you may have thousands of products, but one would like to really focus on some major products and try to see which products go with which other products. That is there any kind of possibilities of cross selling? Are people really buying some combinations together? One set of combinations which could be very obvious. Let us say somebody buys bread, possibly that person may buy butter with that, but there is some combination which may not be very obvious to us. So those are very interesting combinations and can really fetch a lot of value. So how can we really understand that? What are those very unobvious combinations which really can be put together and can really put us ahead of the competition in the retail market? So that is one thing. Second thing is, we would also like to know, let us say two products are bought by customers together. We would like to know the profile of those customers. Let us say somebody purchasing a magazine and a bread together, somebody purchasing an umbrella and a suitcase together. It's a very familiar kind of a combination. But the more important thing is, we would like to know the size of this particular market. How big is this market? If 1 million customers or 1 lakh customers visit my store, what is the size of that particular segment which would really buy this combination together? Because if I know the size of that particular market, that really makes sense for me, because I may have just 5 customers in a month who buy this kind of a combination, and I will put all my resources, energy and marketing promotion into that, and that doesn't really make any sense. So it is very important that I know the size of this particular market. Third thing is, if I know what attracts what, so that I can really manage the display. That means whether magazine attracts the bread, or bread attracts magazine, in a sense that if a customer buys magazine, will he buy a bread, or if he buys a bread, will he buy a magazine? So what attracts what is really important, because that helps me to really display the items in the retail store. Because if I keep the attractor in the first place, it will, and keep the second item far behind, or keep a distance between the second item, then there's quite a possibility the person will really get attracted to the other item, because the first item is attracting the other item. So if I am putting it in the reverse order, is a lesser chance of really getting hooked to the next item. So that is the third thing. And finally, I would like to know really who are the people who are really buying it. What is their profile? And in a very simplistic way, like I should know whether they are like males or females, what is their say age, category, what kind of locale they belong to, everything. If I know, I can do a very targeted kind of say marketing promotion in pushing these kind of products. So how do we really do it? Let us see. So what I have done is I have just taken a demo data from a retail outlet, which you have just seen in the table, which shows you certain say variables, which you can see is the first is card ID. So what has been done is that data about the customers has been captured in a time period which captures their customer ID, their value they have spent, the payment method, whether they have paid through check, cash or card, their gender, whether they are homeowners, what is their income, what is their age, and then there onwards you see all these are different items they have purchased, like fruit, vegetable, fresh meat, dairy, canned vegetable, canned meat, frozen, beer, wine, soft drink, fish, confectionery. So we are just using this small data set with 1,000 records for demonstration purposes. So next what we do now is we have to define this data. So what we do is we just take this type from here and just bring it over here. We will now link this data source to this type. So what we are trying to do, we have to now define the variables. But before we define the variables, we have to read the data. So reading the data means instantiation. That means we are letting the data flow into the model. So we will just press this thing and you find that this data has passed on to the model. Now this, you can really see the data points over here. So only one thing I need to really check is, I will just correct it, so set. So if you see the first column is the fields, that the different variables I have in the data set, and the second one is the type, that is what type of data, is it numeric data or is it say categorical data or qualitative data, or is it nominal kind of a data, which is say yes no kind of a data, which is called flag data, like homeowner yes or no, right? But we cannot have flag for the sex, because we cannot have whether this person is male or not male, and in particular western localities you have to really give a leeway for such kind of say issues. And the final thing is the direction, and the direction is whether the variable is independent variable or the dependent variable, or it is both. So depending on its same say direction, we can really apply a particular kind of model. So each model requires a different kind of say definition of the variables in terms of its direction. So if you see, if I just press it to understand it, so if you see that card ID, we can have in means independent variable, out means dependent variable, both means it is independent as well as dependent. What kind of a situation it will be? We will just explain that, or it is none, or it is partition. We don't really touch upon this to really make things very confusing this time. So we will just try to explain you what is the situation when I say both. Both means the variable is both independent as well as dependent. Let us take a simple case in a retail outlet, and a person is purchasing, let us say 3 items. People are purchasing 3 items, let us say a laptop, a mobile, and let us say a carry bag. Now my interest is to really know whether people who buy laptop, do they also buy mobile phones, and people who buy mobile phones, do they also buy laptops. So in the process, in the first case, when I say if people buy laptops, whether they buy mobile phones, laptop becomes an independent variable and mobile phone becomes a dependent variable. But in the second case, when I say at the same time, I also want to know if people buy mobile phones, whether they buy laptops, at that point of time the mobile is variable is an independent variable and the laptop is a dependent variable. So in the process, each variable becomes independent variable as well as dependent variable. So if we have to do this kind of an analysis, as we are talking about a retail situation, our variables are both in this particular case to begin with. If we want to find out whether people are purchasing certain combinations together, so we will have to define those items as both. At the same time, in the initial analysis, we don't really need the items like say card ID and value, payment method, sex, homeowner, age, which are classification variables, because what is really required, we want to really for the time being just analyze the items which customers purchase. So we'll define it as both, and then we will define from this to the age as none. So we don't need these variables for the timing. We will just focus our attention on the items which customers purchase. So I will just say okay and go next. So what I do now is I go to the graphs to explore this data to see whether there are some visible combinations which can be really seen. So I just connect it to the graph which is used for this kind of an analysis. I select the variables from here to the end. I just say okay and say here. Now all my variables which I want to really explore, I will show true flags only. That means only true combinations of these items will be shown. And then in the options I just put it, let us say 90 and which are more than 110, and I say okay. Now soon you will see the combinations which are very, very powerful combinations across the items will be visible over here. So if I just scroll this particular line over here, you will find the most powerful combinations will appear over here. That means people in the whole lot, customers, 1,000 customers, what kind of combinations they normally go for. That means the people who buy fish also buy fruit and fruit vegetable. The people who buy confectionery also buy wine. And the third category of people, very interesting, are those, I can't really figure it out, this beer, canned vegetable. People who buy beer, they buy canned vegetable and they buy frozen meal together. So there are three kinds of people, three kinds of combinations which are really sold in the market in a very like big way, so which can be really leveraged in the promotion. So once we have done this, the next thing that we would like to really know is who are the people who are really buying it. So what I do is, let us, for example sake, let us just click one of these lines and till it becomes red, I just right click, I generate a new variable from there. I just close it. So you will find a new variable has been created over here by this particular action. If you double click it, you will find it says all those particular records where fruit vegetable is true and fish is true, a true condition is attached for a new variable. All other cases will be taken as false. To check it, we will just show you, but first let me give it a name. Let us say the people who eat now fruit, vegetable and fish, they are healthy guys. So I give it a name to that and I have created a new variable over here. So these are the healthy people. So let me just link it to this particular thing and let us go to the output now. Again bring that table which helps us to see the data at any point of time and link it to this. Okay. Now I double click it and I just execute it. Now what you will see here is the data, same data that we saw in the earlier case, but with one more thing. That one more thing is what? This new record, new variable has been created over here. So if you closely look at this record, what you will really find is that all those cases where, let us say, it is true here, and you will find that here the fish is true and the fruit vegetable is true. So all those cases where this fish is true, fruit vegetable is true, you will find healthy will be true. Rest all the cases where either of these conditions, this condition is not met, it will put a false flag on this. So that was to really help you understand what we have really done in the process. So I will just close this. Now next what we do is we will just again go to record field operations, get this type over here, and we'll have to link this to this particular type. So what are we trying to do now? Because in the earlier case, if you remember, when we tried to visually explore, we tried to find out what are the best combinations that really sell together. That was to really understand the combinations. Now what we are interested in is first, what are the who are the people who are really buying this particular kind of a combination. Now what could be our interest now? That is, now we want to do a kind of a regression of this new variable on the set of independent variables which can give us that kind of a profile. Now, what kind of independent variables? Do we really need fruit, vegetable, canned beer, etc., all those items for this kind of analysis right now? Of course, your answer will be no, because now we are interested in that variable which is now a new variable. That would be our dependent variable, and our independent variables would be the classification variables like age, income, gender, etc. Because we want to know now the profile of the people who go for this kind of a combination. So how do we do that? So we have to again redefine the variable. So we go to the type again here. Now in this case, let us do one more thing. Let us omit this particular thing. I will just do one more thing. So this is a filter here. I will just remove this card ID because it is really creating trouble, because card ID is something which is not really helpful in say our analysis, because it is a kind of a key for the whole data set. So what we'll do is, now we don't have card ID appearing over here because we have filtered this out. Now what I need is, I don't need all these variables now. So I say none. And the last variable which we have created, the healthy, we will say it as out. Now as you remember, I told you in the very beginning, out means dependent variable. So we have used this new variable as the dependent variable. So what we will do is, we will use the first set of classification variables as now input variables. So what we are doing is, actually we are trying to do a kind of a say regression, but of a different sort, to classify people who buy this combination and who don't buy this combination. So a true condition would be when people buy this kind of a combination, and a false condition would be when people don't buy. And for the true condition, what is the kind of profile people have? So that is what we are trying to really achieve. So I say okay, and I have defined these at input in variables, direction is in, so independent variables. So I just press OK. Now what I do next is, I will go to the modeling and use a model over here. So if I take this model, C5 is nothing but a classification model. There are many say facilities in this case. If I just press this classification ever, so we have C&R tree, Quest, Chaired, and C5, all these say modeling versions are nothing but they do same thing. They classify your say they classify a dependent variable based on and give you the profile of the people who go for a true condition and what is the profile of the false condition. This helps us to really focus our efforts on the targeted segment in, let us say, in the case of a retail, this promotional exercise that we just were discussing. So what we do is, we will just link this to this particular thing and we just open it. Everything has been pre-configured. So what we do is, I just simply say execute. Or I have another facility, I may really still do a customized offering, that I am not really interested in all the variables for classification which I have defined so far. I may not be interested in, let us say, payment method. I may be interested in just couple of those particular variables. So I can use custom setting in that case and just click it, and I can choose the variables from here, which in this case I am not really doing. I use the type setting which has been already defined. So what I do is, I simply say execute. Now when I execute, now you would see that this particular thing has appeared over here. Now this particular icon is nothing but the model that has been generated out of by the algorithm which is used by this particular modeling icon. So if we bring this particular icon over here and we want to really connect it to this, then we can browse it also. And if I just open up, you will find there's a rule set which has been now created over here. And if you see this rule set, it tells me that people who are less than age of 24 and they don't own a home, go for this kind of a combination. Very interesting. And people who own the home don't go for. There are false. That is a false condition. That is, now if I want to target my marketing promotion and put my efforts on a specific segment, who are the kind of people who I should really target? Possibly people who are say less than say 24, but who don't own a home is a true condition, so I can really focus on that. Now I may be interested to find out, okay, that is fine, but how accurate is this particular model? I may not be, I have to be really confident about it, whether it, whatever model I have generated with whatever say algorithm it has used, to what extent I can really believe in this. So to do that, what I do is, I have a feature over here which is called analysis. I just bring this tool over here, this icon over here. I just link this model to this particular icon, and which is called analysis. And then what I do is, I just click execute. Now when I click execute, this what is called the confusion table, this particular table gives me the kind of an analysis that what is the level of correct say prediction and level of wrong prediction. So what has happened is, I am 93.8% correct and 6.2% wrong. Okay, so in a sense, what has happened is, I am in say statistical say analysis, normally we say with what level of confidence, 95% level of confidence. So in this case, if I have to really have 95% level of confidence, I will say it doesn't really stand that level, because it is just 93 point something. But if 90% say in say social sciences or certain exercises, even sometimes we are saying even if we are 90% correct, let us go ahead with that. So in that case, yes, we will go with this kind of a model and try to really focus our this thing on this particular combination. Now after we have done this, next thing that we would like to now do is we will try to see which are the items which go together in the whole lot. One, second, which items attract what items, that is which is purchased first and which is purchased next. That will give us some idea about what is the attraction and pull and push between the items. Second, we would like to know the size of that particular market, which gives us additional information to really take say chances and really putting say some resources to promote these kind of products. So how do we really do that? Let us see. So what I do next now is, I will go to this again to the modeling, and I will use a kind of modeling technique which is called association, variable association. And in this variable association, if you see, there are some 4 icons. All these basically help us do variable association. And variable association, by the way, in terms of say technicalities, is based on simple concept of conditional probability. That is, what is the conditional probability of purchasing the next item? That is, if I purchase X item, will I go for Y item if I purchase X item, and so on and so forth. And sometimes we may also like to know, if I buy X, will I buy X2, and if I buy X1 and X2, will I buy really X3. So I have all possibilities to really explore with the help of this simple probability concept, which is called conditional probability. Now that is what variable association is basically developed on. The fundamental say technical say base is conditional probability. Now various algorithms have been developed by different say statisticians to really facilitate different kind of say marketing questions, but essentially all these give this kind of say sequential say pattern in the items which people go together based on the conditional probability. So let us see how we can really use this kind of a model in our case. So let us take this GRI model, and which is association model. I just join with this type. And why I really need now this type again, the earlier type, because in the later type what we did is we just modified all variables. If you see, classification variables as independent variables, negated all say items which were brought except the last item which was put as dependent variable, because here we wanted to classify people based on they are purchasing this combination or not. So that is why we had done that, and we used classification modeling for that. But here what do we want to do? We want to see the people who buy combinations, what the items which are sold as combinations, which are bought as combinations, what is their sequence, how are they attracting each other. That is, what is the precedent item, what is the successor item. That is what we want to really find out. So if you see here, there are again you have two possibilities. You can use the say the settings which are there already defined in the type, or you can use custom settings. That is, you can simply click it and just decide on your own what items you want to really analyze further. So you can just click it and go over here and use what items you want to use in the, as a consequent, and what as the antecedent. So consequent is which is purchased next, antecedent is which is purchased first. So we can really do that, but in this case, for the demonstration sake, I just, to make it easier, I am simply using use type node setting. So what I do is I just say execute. Now this kind of an output appears over here. Now what does this output really mean for us? So if you see this output, it shows you that the consequent is canned vegetable, fresh meat, frozen meal and beer are the antecedents. It means if a customer goes for fresh meat, frozen meal and beer, that person will go with 96.7% confidence for canned vegetable, because that is the confidence level. So people who go for fresh meat, canned vegetable and beer will go for frozen meal with 93.5% level of confidence. So that is what the confidence percentage tells us. Next is the support. Now what is support? Let us say out of 1,000 people, there are some people who buy canned vegetables, some people buy fresh meat, some people buy frozen meal, some people buy beer. Now, what is the percentage of, say, antecedent in the total is the support percentage. So, people who buy fresh meat, frozen meal and beer together. So, probability of fresh meat multiplied by probability of frozen meal, probability of beer, all together happening simultaneously is 3%. Now this is support percentage as you see in this particular software, but you have to be really cautious. Support percentage theoretically, as it has been defined by the statisticians in different, say, articles and research papers, in many cases what they say is the joint probability of antecedent and the consequent together is taken as the support. But in this particular software, if you'll see many, say, models which are used here, will show support percentage as the antecedent probability percentage, probability which is then converted into the in terms of the percentage. Now what does it really mean? Suppose I am a marketing guy and I am really trying to really promote my products in the coming season, and I want to promote, say, certain combinations in the market, because I don't want to focus on every other damn product. So what I do is, let us say I want to really focus on now these 4 items: frozen meat, frozen meal, beer and canned vegetable. The thing is, first I would like to know what is the size of the market. Second is how likely that market is going to really follow what is really coming out of the model. So the confidence percentage tells me how likely it is going to happen that if you promote frozen meat, frozen meal and beer, or give some incentive on that, canned vegetable will automatically get sold with that, because that is a consequent for that. But the most important thing is, first we have to see the base of this particular market. What is the base of this particular market? The base of the market is the proportion of people who buy fresh meat, frozen meal and beer together. Now imagine if the size of this particular market is very small, then even the confidence level is very high. The total market looks quite very small. It is not really interesting for the marketeer. That is why support and confidence both are very important in say establishing a good market and pushing, say, combinations of products, are sometimes what we do, say, helping cross-selling in the retail space. Now what we have done is, for the timing we have just used, say, that by default antecedent and consequent case. So what we can now do is, let us try to see other possibilities that we can really do. So if I just click it and I say to the model, rather than saying maximum number of antecedents is 3, I just put it as 1. and I just click it as executed. It gives me just few combinations. Now, if you remember what kind of items we had really seen in the combination, so you don't really find this combination over here. That means the combination that we really checked over here as the healthy combination, that was fruit, vegetable and fish as true condition. But if we go over here and click it here, you don't find that combination over here. That means even this combination can be visually figured out from, say, the web data, but when we really look at the size of this particular market, it doesn't have the necessary, you don't have the necessary confidence, nor do you have the requisite support that you would like to have for this kind of a combination. So what is really important is when we are exploring this kind of a problem is to really see that it really matches both the things, that there is a sufficient support to begin with, and then we look at the confidence. In fact, many analysts not only look at these two things, they look at another figure which is called the lift. And lift is normally like lift can be 1, more than 1 or less than 1. When we say lift is 1, that means there is no attraction across the items. When the lift is more than 1, that means the items can really go along with each other. And when the lift is less than 1, the items don't, they are like, a person gets withdrawn after you purchase one of the items. Because many times what happens, if a customer buys one of the items, that person even may have really come up may have really thought at the home that I will purchase that another item, but when you purchase one of the items, then you decide, okay, not this time because I have already purchased this item. So there's a kind of a, opposite pushes across, say, combination of the products. So that happens when the lift is less than -1. But what is actually lift? The lift is nothing but joint probability divided by individual probabilities multiplied. Because if you have joint probability more than individual probabilities multiplied together, possibly there is a attraction between the items. That is, there is a likelihood of happening these items together more than these items being individually purchased in the same retail space. So that is what this particular output will help us to figure out. So similarly, you can have possibilities of, like, you can really sort this based on the rule support, you can sort this data based on the consequent, you can similarly you can have the based on the lift, or you can have based on the deployability, because deployability is actually something which can be actually applied in the situation, execution of a particular thing, because many combinations are there which are not really executable. So you have to really see that it is deployable, say, whatever combinations are there. So I will just close it, and next what I will try to really show you is that once you have really taken one model, it is quite possible you would like to see the efficiency of other models as well. So what we do is, I will go to the classification models again, and this time what I will do is I will bring this C and R tree over here. C and R tree is nothing but a similar model like C5, which again does the classification. So let us see what is the efficiency of this model, or is this particular model able to really give us a better thing. So we will just simply execute it. So you find this over here, let us get this over here, we'll just link it and open it. Now if we open it, you find it has given us a similar kind of this thing output. Again, if the age is less than this thing and homeowner is like this thing, the condition is false. If the homeowner is yes, if the homeowner is no, the true, which we also got from C5, the earlier model that we really use. We can again use the this thing analysis tool to cross check whether this model gives what level of accuracy, so that you can really cross check with the earlier model. So we just join it, go here, execute it, again 693.8% accuracy, and this one gives you 6.2% accuracy. Now this is one of the things. Now it is not only this kind of analysis you can do with this particular tool. Let us say even in this case, this particular data, it is quite possible that you may like to really use any other tool that you want to use. And I will just for the explanation purpose, we can just use, let me see whether we can use a neural net. But the neural net is not really a replacement of say classification, but I'm just showing how easier it is to really use neural networks. So if I just attach this neural networks to this type, imagine that this output data, which is in say true and false condition, I just remove that. I just put a numeric variable as as a dependent variable. So what I do, I will just use payment value as the output variable and rest as the input value. And I want to really figure out is there any linkage, what kind of coefficients we can really generate across these input variables or the independent variables if we regress this particular value variable or the total money spent by the customer on these independent variables. So I just simply say okay, I just click it and I just execute it. So you may have any data, any problem, no matter whatever amount of data, thousands, millions of records, simply link this data on the system and in a second you will generate a computationally very powerful technique applied, which we call as neural nets. And this is the kind of, no, what it tells you is the influence of different variables on the final output. That is, income is the most influential variable on the total value spent. Next is the age, third is the payment method, fourth is the sex of the person, and last is the homeowner. So whether you own a home or not is not really going to really matter much when it comes to total value spent. But what really matters is the income of the person. And next is age. So this is another insight that you can really get if you can really work across the independent variables or the classification variables that are there in the data set. So all this in one particular software, and that too just simply you drag it, drop it, generate it, validate it, and whatever you want to really do it, you can do it. And a very fantastic tool, and it doesn't really take much of the time. What it really takes is to really practice it, because it looks clumsy when you really look at this now, this particular model which I have really shown you here. But once you start really working on it, go through it twice, thrice, then you start really understanding and really appreciate the ease of really doing it. It is the companies who really in the initial stage developed software, statistical software, are slowly going into this kind of an interface, user interface, because it makes the whole process of say using the software, applying to say situations much easier for the users. So similarly, you may have a file, let us say in Excel, you can really bring it over here. So whatever data source you have, let us say we have this Excel file which we used for the SPSS. So what I can do, I just brought this Excel icon here. I simply click it and I will simply go to the desktop and just pick that file from there and list Excel as all files. Okay, so these are the files you have already over here. So I can bring this file, or I can bring SAV file, or whatever I can do, because there's a SAV file which was also created by me on the desktop. I can bring any of these files. So I will simply open it and I can really use it. So I just open it and this file is here. So I say filter. But now what has really happened is in this particular version is that the extension XLSX is not basically compatible as of now, because I have not really defined this particular extension in my is not defined in the software. So you possibly have to do ODBC connectivity. So the other way is you just change the extension of the file to make it working in your software. So I go to this particular folder where I have put the CEC file and I just open it, and now I will save it as just a minute, and I will just now save this file, save as CEC, and in earlier version 97 2003, because that version possibly is compatible with my software, SPSS software. So that thing that you have to really take care of. You have to, while you are using such softwares, you have to really see if you are using other kinds of files, the version compatibility. So if I now click it and I again go back, possibly this time I should be able to really uh, see this file. I will just cancel it. Where I have stored it, I am just not able to understand. In just a minute. Okay, so okay, yeah, now you see this file has appeared over here. Now the variables are really seen over here. I can scrap any of the variables, I can add these variables, I can really do whatever I want, and I can really define the type of the variables like I did in the earlier case. So that was a brief, like not a, I would not say really brief, but that was a kind of say walkthrough through say a kind of say modeling process using this particular software. And this is not the only thing that you can do. This is used extensively in customer relationship modeling. This is used extensively in fraud detection. This is used in say all say different kinds of say marketing decisions or financial modeling decisions, or say any other say modeling areas. This software is quite say happening, and the handy software. So that was the kind of say agenda that I had really today to talk about, and hopefully for the next few days we will now start using another software, the base software, SPSS software. I will use those softwares to apply various say specific techniques like ANOVA, regression, and non-parametric statistical modeling. Thank you very much.
Okay, before we end the lecture, just can you explain the 3 or 4 precautions as to one should take while working on this software?
Yeah, so see, when we are using this particular software, what you have to really remember is that the data has to be clean, and should not be really if you have used some formula in the, let us say you are bringing in from the Excel file, if you use some formula, so you better convert that formula driven data into values. Otherwise, when you really run any kind of a technique, it will give you some kind of a trouble. And many times, even yesterday I was showing you, I was using random functions. So if you have generated some data using such kind of a functions, the moment you really link it to the database, to the source option in your software, by the time you start working on it, because the data in the basic table has changed, because it is randomized, so that will give a kind of say in a big trouble. Second is many times what is, there are certain say similar looking icons, filler and filter. So you have to really differentiate the two. Filter has a different purpose and filler has a different purpose. So understand the difference between various icons which are quite similar in nature and can do similar things. Third thing is, when we are using say different models, whether say different classification models or different variable models, you better understand the logic of those particular models and the feasibility of those models, because certain models have been used, developed keeping certain sensitivities in mind. So unless those sensitivities are really addressed and known, you may apply a wrong model in this situation and really not serve the purpose, because some models have been developed to really address, to see that like huge data computation is required. So they are like the computation friendly. So that is how those certain models have been developed. So depending on what kind of say computational power you have in your computers and in your system, so you got to really understand that. You got to see, go to the basic say theory and say document of that particular algorithm, and then apply those. So rather than just putting anything over there, it is better to really read the documentation before you really apply these kind of models. Thank you.
Okay. Well, friend, I hope you must have understood the lecture, though it was technical, but Dr. Wali has explained with examples and very in a lucid manner. So I hope this must be beneficial for all of you. So with this word, I would like to conclude the lecture, and I thank all of you for watching the lecture. And on your behalf, I thank Dr. O.P. Wali for giving such a wonderful lecture. Thank you very much.